Hello, men. Welcome to class today, our first go online. This section is 6.2. We're going to be talking about parallelograms. So first off, I'm going to start with the definition of a parallelogram and get my laser pointer here. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So if I take a look, I see this quadrilateral right here, and I know that this quadrilateral is a parallelogram. Why? Because AB segment AB is parallel to segment DC, and segment AD is parallel to segment BC. Recall that these chunky arrowheads right here on AD and BC, there's one chunky arrowhead. So those let me know that those two lines are parallel. I have two chunky arrowheads on segment AB. I also have two chunky arrowheads on segment DC. That's how I know those segments to be parallel. So that's just the definition of a parallelogram. If we look over here with our notes, to name a parallelogram, there is a special symbol, and it's just a quadrilateral. It looks like a parallelogram. So that symbol is parallelogram. So again, in parallelogram ABCD, I know that segment AD is parallel to segment BC, and segment AB is parallel to segment DC by definition. That's one of the many properties of parallelograms, and we're going to take a look at a few more. Starting off with theorem 6.3, it states that if I have a quadrilateral that is a parallelogram, then opposite sides are congruent. So here I have parallelogram JKLM. I see that segment JK and segment ML, those segments are congruent. They are opposite sides. They are across from one another. And then I take a look and I see that segment JM will be congruent to segment KL. So again, I'm looking for segments that are across from one another. So if you're having issues, opposite sides, think opposite sides are on the walls that are to the east and west. Here I have JK and ML. These are on the north and south. So those are opposite or across from one another. If I look at theorem 6.4, it says if a quadrilateral is a parallelogram, then opposite angles are congruent. So if I look right here, angle J and angle L, they are across from one another. So that means that angle J is congruent to angle L. If I look right here, I see angle K, I see angle M. Again, these angles are opposite or across from one another, so we would say angle K is congruent to angle M. Moving on with our theorems, if I look at theorem 6.5, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So, men, we've discussed these type of angles before. Back in chapter 2, I see that segment JK and segment ML, I was told that those segments previously are parallel to one another. Then remember, JM is what I would call my transversal. So what do I know about angle J and angle M? Angle J and angle M are supplementary. They're consecutive interior angles. So that is why the measure of angle J plus the measure of angle M must equal 180. I could also look at it as segment JM and segment KL being parallel. Then that means that segment ML would be my transversal. So we've talked about this again previously. So that means that these two angles right here, angle M and angle L, they have to add up to 180. Again, if JK and ML are parallel, KL is my transversal. So angle K and angle L must equal 180. So just know that consecutive interior angles are supplementary. So it could run north and south or east and west. X and Y will add up to be 180 degrees. That's what it means to be supplementary. We've kind of saw theorem 6.6 again back in chapter 2, but it states this: if a parallelogram has one right angle, then it has 4 right angles. And that's kind of, again, going back to the theorem 6.5. If JK and ML are parallel and JM is my transversal, and I know angle J to be 90, then that means angle M plus angle J must equal 180. So therefore, angle M has to be 90. If I have segment JM and segment KL being parallel, then JK would be the transversal this time. So that means that angle J plus angle K must equal 180. And if angle J is 90, that implies that angle K is 90. And we could work our way around this parallelogram, and we'll find out that if we do, then angle L would be 90 degrees, and angle M would be 90 degrees. So if I have one right angle in a parallelogram, then that follows that I have 4 right angles. So let's look at example number 1. It says, in parallelogram ABCD, suppose that the measure of angle B is equal to 32 degrees. So I'm going to write 32 degrees here. And segment CD is 80 inches, so 80 inches. And then I also know that segment BC is 15 inches. I need to find the length of segment AD. I need to find the length of segment AB, find the measure of angle D, and then find the measure of angle C. So it goes back to our previous theorem that if I know that DC is equal to 80, then opposite sides are congruent, so that means segment AB is also 80 inches. Same reasoning for segment BC. If it is 15, then that means that segment AD is also 15 inches. Carrying on, if I know that angle B is 32 degrees, there's the theorem that says angles opposite of one another are congruent. So it stands to reason that angle D is 32 degrees. And then I have to use the theorem that states that consecutive interior angles are supplementary, or consecutive angles are supplementary. So now in order to find whatever the measure of angle C is, I'm going to say that 180 minus angle B is the measure of angle C. So when we subtract 32 from 180, we get 148 degrees. So there you have it with example 1. Looking at example number 2, I could just fill in the opposite sides right here. I know that AD is going to be 20, and I know that AB is going to be 30. I also know that angle C will be 36. All of these have to do with opposite sides being congruent. So AD and BC are congruent. They're opposite sides. CD and BA are opposite sides. So that's why AB is 30. If I look over here, angle C is 36 because opposite angles are congruent. I'm just going to go on and fill in what is the measure of angle B. So I know that the measure of angle B is equal to 180 minus 36. And when I do that, I get 144 degrees. And now that I know that angle B is 144, I know that angle D is also 144 degrees because opposite angles are congruent. So you should have the following in your notes: that AB is 30, angle D is 144 degrees, and the measure of angle C is 36 degrees. Okay, we're going to take a look at 2 more theorems about parallelograms. So if a quadrilateral is a parallelogram, then its diagonals bisect each other. And remember this word bisect. If I say bisect, it means to cut in half. So if I look over here, I see that AP and PC will be congruent. I'm going to put 3 tick marks in there, and then 4 tick marks on DP being congruent to segment BP. So that's what it means to bisect each other. And lastly, theorem 6.8, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So if I was to label over here triangle 1 and triangle 2, you see that triangle ABD would be congruent to triangle CDB in this congruency statement. I'm not going to ask you guys to prove it, but hopefully you'll be able to see that the parts would match up. We know that AD is congruent to BC because opposite sides are congruent. Same thing for AB and DC being congruent. And lastly, I could say that BD is congruent to itself by the reflexive properties. So I hope that you guys can see that these two triangles are congruent by side, side, side. Looking at example number 3, if I wanted to solve for R, I noticed that there's an R right here. So 4R would equal segment ZY, or WX would equal ZY. So I get that 4R is equal to 18. In order to solve this equation, I'm going to need to divide both sides by 4. And I get that R is equal to 18 over 4, which we know is 9 over 2. So you guys can write your answer as 9/2, but you like to write it as 4.5. So R is 4 5/10. If I wanted to solve for the variable S, I'm going to take a look, and I see over here that 8S is going to be equal to 7S plus 3. And I'm going to state that because that's the diagonal. And remember, the diagonals bisect each other. So 8S equals 7S plus 3. So if I wanted to solve, I'm going to go on and subtract 7S from both sides. When I do, we get S is equal to 3. All right, zoomed in so that we could solve for the variable t. I see that ZY is my segment. I see that WX is my segment. I know that WY will be my transversal. So we were told a long time ago in chapter 2 that two parallel lines cut by a transversal means that alternate interior angles are congruent. So here I'm going to set 2t equal to 18. We divide both sides by 2 and get that t equals 9. So that was example number 3. Okay, our last example. If I wanted to solve here for the variable x, I see that DB right here, and I see that AC, these segments are the diagonals of that parallelogram, and I notice that they bisect each other. That's one of our theorems that we learned. So in order to solve for x, I set 6x plus 2 equal to 4x plus 12. And I have to solve this equation. We're pretty talented as a class at solving these. We've seen them all year long. So we're going to go on and subtract 4x from both sides. That gives me 2x plus 2 equals 12. Now we're going to subtract the 2 from both sides. We get 2x equals 10. And we need to divide both sides by 2. We get x equals 5. If I look back over here and I want to solve for p, I see that opposite sides here, I have segment AB and I have segment DC being opposite sides. So I'm going to set 2p equal to 22. This is a quick one-step problem. We divide both sides by 2 and we get that p equals 11. And lastly, if I wanted to solve for k, I'm going to look. I've got the two green lines. Those lines are parallel by definition of a parallelogram. I see right here that segment AC is my transversal. So I'm going to set 3k plus 4 equal to 25. And in order to solve that, we subtract 4 from both sides. We get that 3k equals 21. Dividing both sides by 3 gives me k equals 7. So that's it for our notes for section 6.2. Hope you guys have success with the homework. And remember, do not hesitate to open the discussion page in Schoology if you guys have questions. Have a great day.